Welcome to Calculus Practice Derivatives. This is a practice set with solutions of various functions that we will be taking derivatives of. We're going to start simple, and that's the first one's always going to be simple to get people acquainted with and a little confidence building. So we're going to look at the derivative of f of x equal to the square root of x plus 2 over x cubed. This is simply a derivative of the form x to the n. So what we're going to do is break this into two fractions. The square root of x over x cubed is x to the negative 5/2, and the derivative of 2 over x to the negative third is what we're going to be looking at. So we have two x to the n forms. And the derivative is n, so this one is negative 5/2. X to the n minus 1, x to the negative 7/2. And here we're going to have 2 times the negative 3 is the negative 6, x to the n minus 1, x to the negative 4th. So I'm not going to bother simplifying these and putting them into pretty forms. Our goal here is to do the calculus, and to be honest with you, how the answer looks is really incidental. Now here we're going to find the derivative of f of x equals x squared times 3e to the x. So we have a product. So the product rule says we take the first function, in this case it's x squared, times the derivative of the second. The derivative of 3 e to the x is 3e to the x. E to the x is that unique function that is its own derivative, plus the second function, the 3e to the x, times the derivative of x squared, which is 2x. So the 3 times 2 is 6x e to the x. Now we're going to use the chain rule. Find the derivative of f of x equals the cube root of x squared plus 6. Okay, so the derivative of the cube root of x squared plus 6 is going to be, this is something to the 1/3 power. So it's going to be 1/3, so here's the 3. The something, x squared plus 6, to the negative 2/3. So the cube root will now be in the denominator, and here's the 2 over here. So the x squared plus 6 to the negative 2/3, which I'll express like this. Then we take the derivative of the inner x squared plus 6, which is 2x. The derivative of the 6 is 0. So that is a derivative. Now we're going to have the quotient rule. Find the derivative of f of x equals sine x over e to the x. We're also running into a trig function. Things are going to come together. Well, the rule is that we take the denominator, e to the x, times the derivative of the numerator, cosine x, minus, and the negative sign is part of the formula, the sine x, the numerator, times the derivative of the denominator, e to the x, over e to the x squared. And e to the x squared is the same as e to the 2x. In this case, we can factor out and cancel an e to the x, and we're left with cosine x minus sine x over e to the x. Find the derivative of f of x equals sine x cosine x. This is a product. Now, taking the derivative of the sine and the cosine are a little different. So we're going to get the first function, the sine x, times the derivative of the cosine x. And the derivative of the cosine x is negative the sine x. Plus the second function, cosine x, times the derivative of the sine x. So we get negative sine squared x plus cosine squared x. Find the derivative of 6 to the x squared. This is going to actually involve implicit differentiation. We never know what form we're going to have to use out of all the rules. So for this type of function, we would take the logarithm of each side. The log of f of x is the log of 6 to the x squared. And a rule of logarithms allows us to take the exponent, x squared, and make it a multiplier of the log 6. So we have to use the rules of logarithms. Now, we don't really have f of x isolated. We have the logarithm. So when I take the derivative of the left side, I get the derivative of f of x dx times 1 over f of x. So that's implicit differentiation. You get the derivative of this logarithm is going to be 1 over. And then we have this, by the chain rule, we have to take the derivative of f of x, and we get the derivative. The other side, the log of 6 is a constant. So the derivative of x squared is 2x. So now we multiply both sides by f of x, which we do know f of x is 6 to the x squared. And so we get the derivative, which is what we wanted, equals 2x, the log of 6, times the original function, which is 2x, the log of 6, times 6 to the x squared. That's a nifty little trick, and it is very useful. Find the derivative of f of x equals sine x squared plus 1. Well, we're going to take the derivative of the sine of something is going to be the cosine of something. So it's the cosine of x squared plus 1. And then by the chain rule, we're going to take the derivative of the inner form, the x squared plus 1, and that's 2x. So it's 2x cosine x squared plus 1. This is an interesting problem, and it occurs often in textbooks and on tests, something like this, or something even simpler than this, and students have a tendency to work this wrong, but it's very easy. Find the derivative of f of x equals e plus x. The answer is 1. The derivative of x to the first is 1x to the 0, which is 1. The derivative of any constant is 0. Notice there is no exponent on E. So the derivative of E with no exponent is 0. And I'm seeing a lot of textbooks that'll just drop that in a problem set, or recommend it as a problem on the test. And students will always write e to the x right here. They just program that the derivative of e to the x is e to the x, and they don't look for the exponent. Be very careful. Okay, now here we're going to find the derivative of f of x equals x, e to the 2x plus 1. Now, we can't use the product rule on the expression 2x plus 1. It just doesn't work. Again, what we have to do is take the logarithm of each side. So the logarithm of f of x is the log of x to the 2x plus 1. And we take the exponent by the use of the laws of logarithms and write it as the product of 2x plus 1 log of x. Now, implicit differentiation over here gives us df dx times 1 over f. On this side, we actually now have a product rule. So we have 2x plus 1, the first function, times the derivative of the second, 1 over x, plus the second function, log of x, times the derivative of 2x plus 1, which is 2. We still have to multiply both sides by f of x. So the derivative, which is what we wanted, is f of x times that whole expression, or x to the 2x plus 1 times the expression 2x plus 1 times 1 over x plus 2 times the log of x. So that one was involving quite a few different things, but all the parts are easy. Take them one at a time and you will get to the answer. Okay, find the derivative of f of x equal to the square root of x times the square root of x to the 5th minus 3. This is a product rule. So we're going to get the first function, square root of x, times the derivative of the square root of x to the 5th minus 3. So that's x to the 5th minus 3 to the 1/2 power. So we get 1/2. So here's the 2. X to the 5th minus 3 to the negative 1/2 power, or we move that to the expression to the denominator. And then we have to take the derivative of what's inside. The derivative of x to the 5th is 5x to the 4th, and the negative 3 contributes nothing. Then we get the second function, square root of x to the 5th minus 3. And here we take the derivative of x to the 1/2 becomes 1/2, so that's 2. X to the negative 1/2, and here's the square root of x in the denominator. Yeah, I really don't care a whole lot about the fact that we have radicals in the denominator. Uh, One thing that people tend to overlook is why. It's not just to make the function look pretty, to get radicals out of the denominator. Many years ago, I won't tell you how long, when I first encountered square roots, there were tables that gave them to about 10 decimals. And it was a lot easier to take, say, a number times square root of 2 than it would be to divide a number by the square root of 2. So if I wanted to make the problem simpler and have multiplications by 10-digit numbers, rather than divisions, which would have been long division by a 10-digit number, I would have simplified the function by removing radicals from the denominator first. With calculators, that really has lost its meaning. Okay, here's another one that's not too complicated. Find the derivative of f of x equals the cube root of 1 plus 4x to the fifth. So we look at this as this expression, 1 plus 4x to the fifth to the 1/3. So we're going to have 1/3, here's the 3. The cube root of 1 plus 4x to the fifth squared times the derivative of what's inside. The derivative of 1 plus 4x to the fifth is 20x to the fourth. Now we get a derivative of f of x equals the natural log of quantity x to the fourth plus x squared. Well, the logarithm of a function is 1 over. The derivative of the logarithm is 1 over the argument of the function. So here the derivative of the log of x to the fourth plus x squared is 1 over x to the fourth plus x squared. But we also then have to deal with multiplying put the numerator by the derivative of what's inside. And the derivative of x to the fourth is 4x cubed. The derivative of x squared is 2x. This one, it's just obvious that we can factor x out and cancel. So it's 4x squared plus 2 over x cubed plus x. Well, thank you for watching, and we have quite a few other videos, especially derivatives and integrals, and there are more coming all the time. Some are practice problems, some are the theory, and so on. If you liked the video, I would hope you would hit the subscribe button and come back and visit some of the others. Thank you.